Due to global warming that continues to intensify, abnormal climate conditions such as heat waves, heavy snow, typhoons, and forest fires are frequently occurring worldwide. In Europe, Germany and Belgium have record heavy rains for the first time in 1,000 years. Heat waves continue in North America, such as Canada and the United States, and heavy rains have caused massive damage and loss of human life in Asia, particularly China and Japan. In South Korea, socioeconomic damages have been serious because of record heat waves, heavy rains, and cold waves. Responding to the climate crisis is no longer a long-term task, but an urgent issue directly related to survival, and it has developed into a situation that requires specific and prompt action. To strengthen global climate change responses and greenhouse gas reduction efforts, the Paris Agreement was adopted as a new climate response regime aimed at curbing the global average temperature rise within 2 degrees Celsius and further lower it to 1.5 degrees Celsius. The UN requested its member countries to establish and promote a long-term low greenhouse gas emission development strategy to achieve the goals of the Paris Agreement. The importance of climate crisis action is being emphasized around the world, and international discussions are spreading, including the participation of 120 countries around the world in declaring the aim of achieving carbon neutrality, net zero. In order to eliminate greenhouse gas emissions, the Green New Deal aims to remove greenhouse gas emissions by pursuing policy reforms to transform the economic and industrial solve the climate crisis and transition to a low-carbon and eco-friendly economic system and provide economic stimulus at the same time. South Korea is also actively responding to the global climate crisis by establishing the goal of pursuing the Green New Deal and carbon neutrality, transitioning to become a low-carbon and eco-friendly country, and announcing the finalized government plan for 2050 carbon neutrality in 2020. K-Water, South Korea's #1 renewable energy company, is trying to find new value in eco-friendly floating photovoltaic power using the water surfaces of reservoirs and hydrothermal energy using temperature differences in water, away from the traditional value of new and renewable energy using water supply and hydroelectric power generation in the process. Starting with hydroelectric power generation in 1973, K-Water's new and renewable energy projects have been developed, such as Sihwa Lake Tidal Power Station in 2011 and Hapcheon Floating Photovoltaic Power System in 2012. These new sources of renewable energy have a total capacity of 1,365 megawatts of power generation. Let's look at the theory and characteristics of photovoltaic power generation. Photovoltaic power generation is a type of power generation using a photoelectric effect, a phenomenon in which electrons protrude from the surface of the metal when light above a certain frequency is illuminated on the metal. A solar cell is a power generation element that directly converts light energy incidence from the sun into electrical energy. For solar cell materials, it generally uses semiconductors such as silicon and is structured by bonding p-type and n-type semiconductors that have different electrical properties. When light touches the solar cell, light energy is absorbed into the solar cells, electrons and holes are generated by the photoelectric effect, and electrons with negative charges are separated into N-type, and holes with positive charges are separated into P-type to generate electricity. The solar cell is called a cell. The module puts cells together in one plate, and the array is composed of series and parallels depending on power generation voltages. The floating photovoltaic power system is a convergence facility that combines solar energy and marine technology, and is a facility that generates eco-friendly energy by installing solar modules on the surface of a dam reservoir. The floating photovoltaic power system is a power generation facility that floats a solar module on the water surface using buoyancy and mooring devices and transmits, sending electricity to the power system through inverters and power substations on land using underwater cables. The floating photovoltaic power system is characterized first by the effect of creating a pleasant air environment without worrying about fine dust, reducing carbon emissions, and cutting greenhouse gases by replacing fossil fuel generation. Second, it is also characterized by being able to use national land efficiently because it is installed on the water surface of a dam reservoir, which means land, mountains, or farmland do not need to be cleared to create space. Third, unlike a photovoltaic power system, it has a cooling effect since it is installed on the water surface of a dam reservoir, which increases power generation efficiency compared to a photovoltaic power system. Fourth, it has been analyzed that the building of a fish spawning ground has the effects of increasing the number of fish under the floating photovoltaic power system and preventing the occurrence of tidal currents by blocking sunlight. This floating photovoltaic power system is structurally composed of 5 main facilities: the solar module, buoyant object, mooring device, underwater cable, and connecting facilities for inverters. Let's take a closer look at the system. First of all, the floating photovoltaic power system uses eco-friendly, wet-proof solar modules that are more efficient in waterproof and rust prevention than solar modules on land, and the buoyant object uses a floating body that can minimize buoyancy loss due to wet-proof in case of damage to the internal filler. For the mooring device, concrete anchors are installed to prevent repulsion by the water level and twisting from and to north, south, east, and west. Direct current transmission underwater cables are installed to transmit electricity produced by the photovoltaic power generation module to inverters on land. It also consists of connection facilities such as inverters and a power substation to incorporate electricity into the power system. Let's take a closer look at each component. A solar module refers to a solar cell that converts solar energy into electrical energy through a photoelectric effect, and a module consists of a frame, glass, encapsulant, backsheet, cell, and connector, etc. The frame is made of aluminum and performs module protection and heat dissipation functions, and the glass serves as a cover to protect the surface. Moreover, the encapsulant protects from external shock and transmits sunlight. The backsheet uses materials such as polyester, PET, to improve the module efficiency due to high reflectivity and protect solar cells from the external environment. The solar cells perform the function of generating electricity from sunlight through photoelectric effects, and the junction box collects electricity generated from the solar cells and connects it to the outside. Considering that the power generation module exclusively for floating photovoltaic power is installed on the surface of a dam reservoir, it uses eco-friendly products with high durability. In particular, it uses a wet-resistant solar module that does not contain lead, Pb, and has improved encapsulation, PoE, that does not generate acetic acid, and enhanced waterproof, dustproof IP grades. The purpose of the Buoyant Objects is to install and fixes power generation facilities, such as solar modules, at the desired angle so that they can float on the water surface. It must have sufficient buoyancy and resiliency. The types of buoyant objects are classified into buoyancy integrated types and structural types according to the way they support the solar modules. The buoyancy integrated type has excellent constructability and lower construction costs than the structural type, while the structural strength is somewhat weaker than the structural type. In addition, there are disadvantages including difficulty in replacing buoyancy during maintenance. It is mainly installed in reservoirs and ponds that are shallow and have little change in water levels. On the other hand, the structural type has excellent stability against wind, tidal power, and wave loads, and a higher structural strength compared to the buoyancy integrated type. So K-Water mainly adopts and uses the structural type to areas with deep water and big changes in water levels such as dam reservoirs. The mooring device stably fixes the floating photovoltaic power to the desired location in response to environmental changes such as the water level. The types of mooring devices are divided into a sinker mooring method that suppresses the mooring's flow by attaching a sinker to the main points of the mooring lines, and an elastomeric mooring method that improves responsiveness to fluctuations of buoyant objects. Recently, K-Water has adopted, installed, and operates the elastomeric mooring method from the long-term perspective, given equipment stability. The underwater cable is a DC power transmission cable to transmit DC electricity produced by the photovoltaic power modules to connection facilities such as inverters on land. Underwater cables are connected underwater, so messenger wires are used to prevent cables from stretching or interfering with other facilities and keep them safe. Solar cells basically produce direct current electricity. The inverter converts DC electricity produced by solar cells into AC electricity. The main functions of the inverter are to supply stable AC power of constant voltage and constant frequency and operate in parallel with the system line by receiving DC power from the solar modules, and to automatically operate and stop for maximizing the output of the solar modules that fluctuate depending on climate conditions such as solar radiation. It also has a separate operation prevention function and an automatic voltage adjustment function for protecting the power system, and a function of safely separating and stopping the inverter from the power system when an abnormality occurs in the power system. The inverter configuration model is largely divided into three categories: central inverter, string inverter, and power stack inverter. Let's take a look at each of the methods. The central inverter method has the advantages of minimizing an installation area, simple and easy maintenance, and a maximum output in a high solar irradiance by installing one inverter on multiple strings. Its disadvantages are that its power generation efficiency is low and the entire system cannot operate in the case of inverter failure. The string inverter. Next, let's look at K-Water's case of floating photovoltaic power development. Korea Water Resources Corporation started using photovoltaic power generation in 2007 by utilizing idle sites such as water treatment plants, intake pumping stations, and booster stations. At present, 8.9 megawatts has been installed and operated, and 10,636 megawatt-hours of clean energy, which can be used by more than 10,000 people per year, is being produced. In addition, since 2009, the pilot plant of the floating photovoltaic power using the water surface of dams has been in operation and was successfully commercialized in 2012. Currently, floating photovoltaic power generation facilities of 5.5 megawatt are installed and being operated on the upstream of Hapcheon Dam, Buoyant Dam, and Chungju Dam, and more than 75 megawatt-hours of clean energy per year is being produced, which can support the demands of more than 7,500 people. K-Water has researched the potential amount to develop 2.6 gigawatts at 19 dams for 2 years through a resource survey on floating photovoltaic power, and we have plans to complete the development by 2030. The picture you see is the 41 megawatt Hapcheon floating photovoltaic power system built in the shape of a lotus flower, which is currently under construction. Since floating photovoltaic power is built on the surface of the water, there are various things to consider when designing it. Let's take a look at them one by one. For the first design factor, it is necessary to conduct a stability analysis of wave height, considering the average maximum wind speed and the transmission distance, and possible external force conditions. Location conditions for a floating photovoltaic power system should be installed at a location that can maintain a keel clearance of 3 meters or more under the lowest water level conditions, maintain sufficient separation from major facilities such as dam bodies, water intake, and spillway, and pick a location where the safety of facilities can be ensured in the event of a flood. Furthermore, it should meet the conditions of review by a trusted professional institution when it comes to GIS analysis and numerical analysis. In addition, the maximum area of the unit block and the separation distance between blocks are presented as detailed on the slide. Construction methods that may affect the water quality of the dam should be excluded, and restrictions on construction methods and materials for floating photovoltaic power set by the government should be observed too. In addition to establishing a system that can monitor floating photovoltaic power generation at all times, it is mandatory to install measuring equipment such as structural displacement or insulation, and to build and maintain safety equipment such as plans for ship waves, safety railings, and warning lights to avoid collisions with ships fishing around the dam. Next, let's look at the construction procedures for the floating photovoltaic power system. First, machinery and equipment such as cranes are deployed, and a water workplace is built to assemble photovoltaic power generation modules and bring in machinery and equipment. At the water workplace, power generation modules and structures are brought in. The water depth of the location where the system will be installed is sounded, and the power generation facility unit is assembled. A mooring device that fixes the solar equipment so as not to move around on the water surface is constructed, and the power generation facility unit assembled at the water workplace is moved. After the process of connecting the power generation facility units that have moved to the installation location of the floating photovoltaic power system, now is the procedure to shape a unit block as shown in the picture. You will watch the video on the construction of the Buoyant Dam floating photovoltaic power system, built according to the construction procedures described earlier. Let's learn about the inspection and operation management of the floating photovoltaic power system. The floating photovoltaic power system is specifically composed of photovoltaic power generation modules, structures and buoyant objects, mooring devices, and underwater cables, and transmission connection equipment such as inverters. So inspection methods are classified according to installation location and operating conditions. The inspection stage for a floating photovoltaic power generation facility is divided into general inspection to check for damages, contamination, and connection conditions at the site, drone inspection to check for twisting of structures with large areas, deterioration of the solar modules, abnormalities of the elastic mooring devices and underwater cables in the air and underwater, and finally performance of diagnosis to determine the efficiency of the solar modules and overheating of the connection. First, in the general inspections, the inspection of solar modules is generally conducted through a visual check. The worker checks for damage or cracks on the module surface due to the external environment and checks for deterioration inside the module through an infrared thermal imaging camera to the suspected section. Moreover, wires are checked to prevent birds from interfering. If collector panels are contaminated by dust or bird excrement, they should be cleaned by mopping it with water. Buoyant objects and structures are inspected by a visual check on site. In the case of buoyant objects, they should be checked as to whether the surface has been damaged or the fastening bolts have loosened. In the case of the structures, these should be visually checked for whether the surface has been twisted due to external pressure, such as the weight of the solar module, or whether the joints are dislocated. In addition, the frame of the structure is made of POSMAC, a highly corrosion-resistant aluminum alloy steel without risk of corrosion. The buoyancy is made of polyethylene that is generally used for children's toys or milk bottles or water bottles, so it does not produce harmful ingredients. It consists of 6 chambers inside to maintain buoyancy in the case of partial damage. Buoyant objects and structures are inspected visually on site. For buoyant objects, these should be checked whether the surface has been damaged or if any fastening bolts have loosened, and for the structures, It should be visually checked whether the surface has been twisted due to external pressure, such as the weight of the solar module, or whether the joints are dislocated. In addition, the frame of the structure is made of Posmac, a highly corrosion-resistant aluminum alloy steel without risk of corrosion. The buoyancy is made of polyethylene that is generally used for children's toys or milk bottles or water bottles, so it does not produce harmful ingredients. It consists of 6 chambers inside to maintain buoyancy in the case of partial damage. The module connection panel collects electricity produced by photovoltaic power generation modules connected in series and parallel and sends it to land transmission connection facilities. Using a DC clamp meter and multi-tester, it measures DC current and voltage and checks the module when each channel indicates different current. In addition, we are checking with an infrared thermal imaging camera to find possible deterioration of the internal electrical equipment to be connected. Surge protective devices are generally installed inside the connection panel. During an inspection, it is possible to check whether an abnormal voltage has occurred in the equipment inside the connection panel by determining whether the counter of the surge protector is operating or not. The power transmission connection equipment is used to convert direct current produced by floating photovoltaic power modules into alternating current through inverters and transform it into a voltage suitable for the KEPCO system and transmit it. It consists of outdoor panels, inverters, transformers, breakers, and protective relays. As for the inspection of the power transmission connection equipment, the inverter operation and condition should be checked and the filter should be replaced regularly. Also, the winding temperature, BSR noises, and offensive odors should be checked. The tightening of the connection part terminals such as cable connection should also be checked. For your reference, KEPCO is a public company like K-Water that manages power generation in Korea. Next, let's look at inspections done by drones. A drone inspection is conducted by being divided into air drones and underwater drones. The air drone allows for systemic and scientific maintenance because it can check for any damages and deformations of photovoltaic power facilities installed on a large scale, as well as a hotspot defection of the generation module by utilizing infrared thermal imaging cameras. The underwater drone checks for abnormalities in buoyancy and underwater cables. It was introduced for unmanned safety inspections and operation management to protect facilities and lives in underwater environments that are difficult to access and high risk. Let's find out how to inspect the solar modules using an air drone. The inspection checks for contamination and external damages of large-sized solar modules and the internal failure of the module through infrared thermal imaging.
안녕하십니까. 저는 한국수자원공사 충주권지사에서 근무하는 길명재 대리입니다. K-워터에서 운영관리 중인 청풍호 1 수상태양광에는 태양광 발전 모듈이 약 8,800장이 설치되어 있습니다. 점검 효율 향상을 위하여 드론 점검 도입 기법을 도입하였으며 점검 항목으로는 첫 번째 태양광 발전 모듈, 두 번째 구조체, 세 번째 부력체, 네 번째 선박 접근 시설 등이 있습니다. 특히 태양광 발전 모듈은 외관뿐만 아니라 적외선 열화상 카메라를 이용하여 핫스팟, PID 등을 점검하고 있습니다.
The procedure for inspection is as follows. First, the flight path of the drone is set and the direction and location of each group of floating photovoltaic power, buoyant structures is checked. Buoyancy and other structures are inspected by moving the drone. The data achieved by the inspection is analyzed and compared with GPS data at the time of design and completion of the floating photovoltaic power. If cracked or damaged buoyant structures facilities are identified, they are replaced. Inspection using air drones strengthened operational safety by early detection of solar modules and structure failures, reduced time and inspection personnel by frequent inspections using drones mobility, and realized preemptive safety management by applying it to inaccessible and dangerous locations. Also, it has the effect of monitoring green algae and environmental pollution through surface water temperature observation, as well as laying the foundation for operation management using AI in the future by accumulating big data such as coordinates and images of locations and states of structures. Underwater drones are used to check the conditions of buoyancy and underwater cables. This was introduced for unmanned safety inspection and operation management to protect facilities and lives in underwater environments with low accessibility and high risk. The inspection range of underwater drones covers to check disconnection and stripped sheath of mooring devices and underwater cables. As shown on this slide, the underwater drone checks the structure of the floating photovoltaic power system, mooring device, underwater cable conditions, as well as the exact location of the anchor cable fixing blocks installed on the bottom of the severely turbid reservoir, using the multi-beam image sonar of underwater drones. Next, let's look at the inspection case of underwater drones. First, the underwater drone in normal operation should be ready. Since the underwater drone is equipped with an internal camera, it is essential to check whether real-time images are normally monitored and recorded before it is put into the water. As the underwater drone goes down into the water, it checks the condition of cables by water depth, as well as identifies the exact location of anchor fixing blocks on the highly turbid floor and checks for abnormalities using the multi-beam image sonar. As for the effects of the underwater drone inspection, it is possible to prevent safety accidents of human divers and do safety inspections on underwater structures covering a large area through remote monitoring and inspections. In addition, early detection of local failures, underwater structures, and cables can prevent accidents and output reduction. It is expected that digital integrated management will be possible in the future by continuously accumulating big data such as images and coordinate images taken during underwater drone inspections. Let's look at the details of the performance diagnosis. Photovoltaic power generation facilities are characterized by having a gradual decrease in power generation performance and efficiency over time. The diagnosis of connection panel facilities inspects the power generation performance and efficiency degradation by aged deterioration of photovoltaic power generation modules, and measures the voltage and current of discharged capacitors that have been fully charged to diagnose whether there is an abnormality in the degree of change. Through the diagnosis of the connection panel, the reliability of the facility can be secured by deriving the cause of power generation output degradation and failure, and excessive facility investment can be prevented and failure risk can be eliminated through maintenance based on module conditions. For the connection panel facility diagnosis, it consists of PV master, paranometer, connecting cable, and laptop with built-in measurement software as detailed on the slide. The connection panel diagnosis method involves the installation of an insulation meter at an appropriate position after connecting the solar channel terminal of the connection panel. Enter the specification values, and then perform the measurement and IV simulation analysis. Let's watch a video related to the connection panel diagnosis.
네, 안녕하십니까. 한국수자원공사 물종합진단처의 정효근 차장입니다. 저는 지금부터 태양광 발전 설비의 고도 진단 기법에 대해서 설명을 드리도록 하겠습니다. 태양전지는 준공일에 시간이 경과하면 성능 특성이 저하하게 됩니다. 발전 효율이 저하한다는 것은 오손, 파손, 각종 열화 현상이 발생한다는 것인데요. 이것을 검출하려면 기존에 수행을 했던 일상적인 진단으로는 검출이 어렵습니다. 그래서 이거는 전압 전류 시뮬레이션 특성을 이용하고 항공 열화상과 유관 점검을 통해서 방안을 도출을 해야 합니다. 네, 그럼 지금부터 태양전지 설비의 구성과 이 구성에 따라서 저희가 진단하는 방법을 설명을 드리도록 하겠습니다. 태양전지는 각 16개에서 18개의 직렬회로와 수백 개의 병렬회로로 구성이 되어 있습니다. 그래서 이 태양전지는 워낙에 많다 보니까 각 중요 개소마다 이러한 현장 접속반이 구성이 되어 있고요. 이 접속반에는 약 25개의 병렬회로의 그 플러스 마이너스 단자가 구성이 되어 있습니다. 저희는 이 진단기기로 이 각 직렬회로의 플러스 마이너스 단자를 전선으로 연결해서 각 직렬회로의 전압 전류 특성을 시뮬레이션을 하게 됩니다. 네, 이 현장 접속반 내부를 보시면 약 25개의 병렬회로의 플러스 마이너스 단자가 설치가 되어 있습니다. 저희는 진단기기로 플러스 마이너스 단자를 최대 24개까지 연결을 해서 전압 전류 시뮬레이션 특성을 분석을 하게 되고요. 접속반의 내용을 좀 더 상세히 설명드리면 플러스 마이너스 단자에는 전력 전자 소자와 과전류를 보호하기 위한 퓨즈로 구성이 되어 있고, 이들이 하나로 모여서 하나의 직류회로 피더가 인출이 됨으로써 수중 케이블을 통해 현장 전기실로 인출이 되게 됩니다. 그리고 최종적으로는 한전 배전선로로 연계되어서 전력을 판매하게 되는 원리입니다.
Next, we will look at the diagnosis of power transmission and transformation facilities. The power transmission facility serves to transmit electricity produced by the photovoltaic module to the KEPCO system. It consists of inverters, transformers, and cutouts. The main diagnoses are divided into infrared thermal imaging diagnosis, earthing resistance, leakage current, storage battery potential, and internal resistance measurement.
적외선 열화상 진단은 송변전 설비 내부의 고압 또는 저압의 전기설비 열화 및 발열 상태를 비접촉 적외선 열화상 장비를 이용하여 이상 유무를 판단하는 진단 기법입니다.
Infrared thermal imaging diagnosis is a diagnostic technique that determines whether there are any abnormalities with deterioration and degradation of electrical facilities at high or low pressure inside the transmission/transformation facility using contactless infrared thermal imaging equipment. Next, let's look at the measurement of earthing resistance. Earthing refers to electrically connecting electrical devices to the ground to prevent human electric shock, accidents, and facility damage due to leakage current or lightning surges, and must meet the ground resistance below the standard to safely discharge it to the ground. The earthing resistance measurement is to determine any abnormalities by measuring quarterly whether the devices of the power transmission and transformation have a ground resistance value below the reference value and analyzing the data trends. Let's find out about the measurement of leakage current. A short circuit refers to a phenomenon where the cover of the wire or the insulation of the electric device degrades and the current flows to the ground through the metal body. At this time, the flowing current is called a leakage current. As shown in the figures, the leakage current measurement method measures the leakage current using a clamp meter by clamping the power cable for live wires in a lump, and takes an action for the failure if the measured value exceeds the standard value. Next, we will look at the performance diagnosis of storage batteries. In the event of a power outage, the storage battery is used to supply power for various power devices such as breakers and protective relays installed inside the power transmission and transformation facility, and for stable facility operation. The potential and internal resistance of the storage battery is regularly measured to determine whether there are any abnormalities by checking for changes in performance. For this measurement method, the power of the measurement device is first turned on. A black lead wire is connected to a negative terminal of the storage battery, and a red lead wire is connected to the storage battery plus terminal.